Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to evaluate a limit, and it is the limit as x approaches infinity of 1 plus 1 over x. Now, if you notice, the function whose limit we have to evaluate is actually, you can consider it as a sum of two different functions. So, when you're taking the limit of this entire function, you can split it into two limits and then add the two limits. So, we can rewrite this as take the limit of the first function 1 as x approaches to infinity and then add limit of the second function 1 over x as x approaches to infinity. And then we can think of the two limits separately. So, let's consider the first one first. What is the limit of 1 as x approaches to infinity? Well, this is a constant function 1, and that means it's a horizontal line through 1. So, what is happening as x is approaching to infinity? The function will always take that value 1. It will always approach the number 1 wherever x is approaching to, it doesn't matter. So, the limit of a constant is a constant. So, that limit gives us 1. Now, the second limit, what is the limit of 1 over x as x approaches to infinity? Notice that x is approaching infinity, that means x is taking large values eventually. So, this denominator of this function is getting bigger and bigger and bigger, which means 1 over that is getting smaller and smaller. Because you are dividing by a large number, so the entire thing is getting small, which actually in mathematical term means that as x goes to infinity, 1 over x is going to 0. And so, the limit is 1. Just note what this really means is that this function is approaching to 1 as x is approaching to infinity. So, x is approaching to infinity, the function is approaching to the line y equals 1, which means y equals 1 is actually a horizontal asymptote to this function as well. Thank you.